Hello friends, today we are going to discuss strength rating and wear rating of worm gears. This is the one type of application of worm and worm wheel. This is called as a wrench. It is useful to wind a wire or unwound wire or rope. Now we will discuss strength rating of a worm gears. Already we studied beam strength and wear strength in a spur, bevel and a helical gear. We consider beam strength and wear strength because generally gear fails due to the lack of bending strength and lack of wear strength. Wear is a surface phenomena and bending strength. Tooth of a beam act as a cantilever beam, so at the neck there may be a chances of failure, and we can say that failure is due to the insufficient of a bending strength. Now worm and worm materials are different. Material of a worm is stronger than the worm wheel, and we know that we design for the weaker, so we'll go for the worm wheel design here. The design for the strain can be based on the Lewis equation as applied to the worm wheel teeth, because worm wheel teeth generally are spur gears or helical gears. The worm gears are usually designed according to national and international codes. Here is the example of National Code IS 7443 methods for load rating of a worm gears, and this is ISO 14521. This is for calculation of load capacity of worm gears. These are the example of a national and international code. There are a number of codes. With the help of that we can design the worm and worm wheel. Now already we discussed beam strength. The maximum permissible torque that worm wheel can withstand without bending failure is given by the lower of these two values. These are the thumb rules on the basis of experiment. MT1 equal to 17.65 XB1 SB1 module LR D2 cos gamma. MT2 equal to 17.65 XB2 SB2 M LR D2 cos gamma, where MT1 MT2 permissible torque on the worm wheel, XB1 XB2 speed factors for the strength of worm and worm wheel, SB1 SB2 bending stress factor of a worm and worm wheel, M is the module, LR length of a root of a worm wheel teeth, D2 is circle diameter of a worm wheel, gamma lead angle of the worm. This XB and SB are the new terms. Here we can calculate or we can take from the table and graph. We'll see how to select value of XB and SB. XB is the speed factor, SB is the bending stress factor. So for the selection of stress factor we need to use this table. Here various type of material for the worm wheel. According to that material we need to select the value of stress factor, that is SB, and speed factor, that is the XB, we need to select from the graph. This graph is RPM versus speed factor. If we know the RPM we can select the speed factor. Just we need to draw the vertical line and then corresponding horizontal line. Now we will discuss about the wear rating of worm gears. Already we discussed gears are fails due to the worm gear also. The maximum permissible torque that the worm wheel can withstand without fitting failure is given by the lower of the following two values. MT3 18.64 XC1 SC1 YZ D2 raised to 1.8 module. MT4 equal to 18.64 XC2 SC2 YZ D2 raised to 1.8 into M, where MT3 MT4 permissible torque on the worm, XC1 SC2 speed factor for the wear of a worm and worm wheel, SC1 SC2 the surface stress factor of a worm and worm wheel, YZ is the zone factor. We can select the value of XC1, SC and YZ from the table. These are the tables to select the various value of SC.